Hello friends, welcome to the LabTechs. My name is Nasir. Today we have ASUS UX481FL motherboard. I have, however, received with battery. I think it is not charging case, plug-in not charging case. And the guy who has worked on this particular place, the charging IC, there are the too much place. This is the problem in our country that whether you know or don't know, you have to work. So this is my duty to inform you. If you are in the repairing line, you better to update yourself uh, instead of trying hit and try method. So let's come and have a check that I am going to inject power and see the load. Turn on. I think this particular model need not to turn on. It must start by itself. So it is not starting. So come and check the voltage. So do we have proper voltage or not? So I really don't have any information whether this is the NVDC or HPB. So NVDC gives you around narrow voltage around 10 volt, 8 volt, 10 volt or 12 volt, and HPB technology, the charging technology, gives you the same voltage as you inject, like 20 volt. It will provide you entire in motherboard. So I am going to check any hard drive of the motherboard area in order to know that do we have the win voltage or not. So the guy who has suspect only that the motherboard is dead, and he has, it is written here, I think, no power. So it means he wanted to check me the battery also after if it is turned on. So this is the 10th generation motherboard, and I think so. I don't have much information about this model, and onboard RAM. So if you try to find out the board view of this particular model, so you will not find the board view. Only schematic is available. So what I am going to write here, that the IC number. Okay. No, I think different IC is used here. So right here AC. Okay. So what is the name of the IC? SN. Okay, maybe. So this is the IC here, and we have to come on the microscope so that I can show you. Come here. Okay, little bit more. So each and everything we need to find out here. Uh, it is written 24780S. This is what I was searching for, but I did not come across. Okay, so WIN. First of all, the requirement of the charging IC is something that on the last pin, 28 number pin, is the WIN. So I'm going to check WIN on the 28 number. Okay, so we are getting 20 volt on this pin. And what else? The AC direct pin number 6. So come and check 1 2 3 4 5 6. It must be 2.4 volt around. So it is on merely 1.9 volt. Though it has less AC direct, but it is more than 0.6 volt. That is why you will get your region voltage. So it must be on the 24 number pin. Yes. This is the region pin, 6 volt 5.94, it's all right. And AC drive you can expect, no, it will not be available. Maybe it would be liquid damage. It seems that the color is changed, maybe that light appeal. Okay, so the color is changed, and the guy, he has changed few things like here all the things I think is changed here, even charging IC. So uh, let me give you my experience that how should you uh, justify these things. So check 1 and 2 number pin. Okay, so what is the process? This is the 1 and 2. The capacitor must beeps on 19 volt shorting. Even you can confirm from here. You just come here and check one thing, that it must beep uh, mm, from the both side, negative and positive, and it should not be from the ground. Okay, so good value you are getting here, both side. This is the ACP. Sorry guys, this is the ACP and ACN. The same way you have to check SRP and SRN. So it is on pin number 19 and 20. 19 and 20 here. This is the pin. So from the ground it is okay, and it means the value of the connectivity from the both area is good. So what is here? I don't know. So I cannot even locate it. So what is it? And it is missed. So this is the problem. So it has no board view. I have no option left, but in my office the same motherboard is for repairing. The RAM is short and I forgot to bring it at my home setup. I don't know what is this. Later on I will find out. But I'm only concerned with the AC detect. That why it is so less. It is around 1.9 volt. See, 1.7 volt. So what is the calculation says you that you just come here and check this particular area. So AC detect requires this voltage, 20 volt across 27 kilo ohm against 20 kilo ohm divider, and the voltage will pass here, and it must be inside. If you go through the internal logic, which we always teach to our students, that without internal logic you cannot understand what is the requirement of the charging IC and 3.3 and 5 volt regulator and core IC, all these things. So unless you know about the internal logic, you cannot confirm it that what voltage is required here. So first of all I am going to uh, remove the AC detect register to find out that is it the exact register value, because the VCC is present here. And remember one thing, if you are on the divider, or if you are on the two registers, in between two registers, you cannot uh, verify the exact value of the register without removing. So that is why it is better option for you to remove it in order to check. So it is 20, it's good. And what is this? 130. So this is also good. Okay. Now let me power to the motherboard, and in this condition I will see the 19 volt must be here. So I'm going to inject power. Now region will not be available. You can see, you can check here, region is not going to release voltage. It is not possible. Now see here, 20 volt here against 20 kilo ohm. But why you are getting low voltage? So maybe this capacitor. Okay, so once again you go through the checking process. It must be ground. Yes, it is ground. Value is 20 kilo, 19.8, 130, 127. It is written 127 and it is giving me 2 kilo ohm more. Okay, so do one thing, you just have to change it. It is good, but it is not good. So let me find out a motherboard which has the same AC direct area, so that I can find out the exact voltage. So what I have to do, that I have to change the register value. So it is not possible for me to find out 127 kilo at this point of time. So what I am going to do, I will let it be here, and I will change the value of the register. The lower register value, as much you will increase, the more voltage you will going to achieve. So my expectation is here only in between 2.4 to 3 volt AC direct. Okay, so let it be here, and for the time being 20 kilo remove, and here I have 27 kilo ohm in the scrap motherboard. What value you are getting? 27 kilo. So lower down value I am going to increase. However, it was okay, 20 kilo. You just use the higher value of the lower resistor in order to achieve more voltage, and the less amount of resistor value, the less amount of voltage you are going to get. So I'm just for the checking purpose. Later on I will change it with the exact value, otherwise maybe the percentage is written, and that could cause not charging. So I have changed it. Now let me inject the power to the board and see the voltage. There is no variation, nothing else. And voltage, the 20 volt I have checked before, I was not getting. Let's see what does happen. What voltage you are getting here? 2 volt. It is not enough. Okay, so I need here around so let me calculate it. Let me calculate it here. I have calculator. You also see My calculation is not good, sorry for that. uh, I have 20 volt, and I am using here 27 kilo divided by 130 and 27, 40, 50, 57, 157. So I need to get here around this voltage. However, I am using the higher voltage in order to achieve, but there is a something problem. Registers was good. I think the problem is somewhere else. So according to this calculation, I need to get this amount of voltage, but still I am getting here low voltage. So the problem may be in the IC or maybe in the VCC. So VCC is good, 20 volt. Register is good, but still I'm getting the low voltage. So what is the reason behind it? So let's fix the same value which it was. Okay, where is the problem? Let me show you. That is why he was struggling, because the new logic which comes you need to adopt. Sorry guys, I have removed it. Come on. I have lost. Yes. Fix it back. Same 20 kilo I am using here, which I have removed. As it is. Everything I left as it is. Clean it and find out one important point. So it is the diagram, and you just copy this point. You just copy the name which is written. The new IC is, or new motherboard is coming with the AC detect logic. If there is an improper ID, or if the ID is missing, or something goes wrong, shorting takes place, if this type sort of things happens in the motherboard, so it will chock your AC detect, and that will not allow your motherboard to be to release your DC in voltage into your motherboard. So this is the logic here, protection logic. Okay. Many Acer gaming Predator models and ASUS models and many series, you will find out the AC direct protection logic, AC short protection logic. So but the problem is in this motherboard that you have to locate the area, because you don't have board view of particular model, but I will try to find out. It may take some time. I will pause for a few moments in order to find out, because this is the not very common model, this is the rare model, and seldom it comes. So what I will do, I will try to find out that exact location of this area. I think that this is the very place where we were on this area where we were, the register was missing or it was moved. I think this is the place. So however, I have to find out. So just wait for a moment. I'll have to find out so that I will save your time. So guys, uh, this is the place where this particular AC direct is going to. So see here, this is the your register. This is the your register. Okay, AC direct, and here is the pin which is having a beep sound. Okay, so what is this? So all this logic where already the work is done. Also I have checked this area because I was checking it that DC in entire area is worked. So the guy, he has messed this motherboard. However, we have to repair it, and the problem is that I am not having the board view of this model, but despite I will try my level best, because particular this 2 capacitor I am scared about it, that if anything happens, but I will show you inshallah that the process of checking these types of motherboard. So now come to the diagram so that I can make you understand that how does it work. See, what will happen, I am getting low voltage at the AC direct. So, and this particular pin is connected after this divider, it is connected from here in between to after divider, it is connected to this area. So this is the production logic. This is the production logic, short circuit production. So now what should be here? So this is the main point, it is having a beep sound, so that is good. So after removing it, it must be increased. As I'm checking here, still it is around 1.7 in between 1.7 to 1.9 volt, but it must be, as per calculation, it must be around 2.6 volt. So as soon as if you remove this diode, the voltage must goes it must go up. And what is this? So this is the after second MOSFET voltage, and this is the first MOSFET. So see here, this is the adapter dock in, and this is the AC battery system. So this is your charging IC, and see, AC bat system. After first second MOSFET you are getting AC bat system, and here what you are getting here, adapter dock in. So both things are there. So you must have a voltage on the uh, at that point, AC dock in, as well as you need to get. But if there is the shorting in your motherboard, or there is some problem in the motherboard, AC bat system would be missing. So go to back here. So what I am telling you, this must be available. So now check this particular point. Do you have this voltage or not? So where it is? So let's plug to the power, and this is the resistor on the above side. So this is the resistor. Do you have 20 volt, which is coming directly from the DC jack? Yes, you are having, but you need to get also this voltage on this area, but you are not having voltage. See here, you are not getting voltage on this area. You are getting voltage on this point, but you are not getting this the voltage on this area. Now here you are having voltage on this point, but not this point. This diode must be off. Okay, this diode. So if you have voltage on, let me with the tools, customization, and where is my pen? Okay, so if you have 20 volt on this area, and also you have 20 volt on this area, this diode will be off. This is what we are needed. If this is on, so what will happen, that if this area is short, V system is short, after first and second MOSFET, after the CLR register, if the voltage is short, So what will happen? The all the voltage will go to the drain. It will be go to the ground. So if you remove it, so AC detect voltage, also the AC detect voltage is dropping across this diode, okay, to the ground. So maybe the shorting is here. So you need to check the shorting only. So that is how nowadays all types of Acer Swift model, new Acer Helios, Acer Predator, ASUS, there are so many models where you have to go across this AC short circuit protection circuit. So this is the only concept, that this is the DC jack and this is the after second MOSFET. There is the sensing register, and this sensing register should not be short. If it is short, you are not going to get the voltage. So first of all, I would like to show you that here AC direct I am getting, because my AC direct is dropping across this diode. See here, I am having a bips on from here. So what voltage you are getting? There is the exact divider. The same divider is available there, despite we are not having the good voltage here. So see here, it is dropping. Okay, so now do one thing, you remove this in order to check only. You will not get solution, and because you have short circuit in the motherboard maybe. So after removing, you just verify it that you have the proper voltage if you have suspicion on the AC detect register. So unnecessarily we have wasted our time on the AC detect logic. Now just power in again and now check the voltage. So you see here 2.6 volt we are getting. That is absolutely all right. It means all the problem containing on this point. Okay, so what is it? This is the system voltage after second MOSFET, after sensing register. Now put it back. So we just have verified that our uh, charging area or the AC detect area is absolutely fine. My charging IC is good. Everything is verified here. Now we have to find out this area shorting, where it is on this area, V system. So on the pin number 2. So check this. Uh, you can check also on the sensing register, and this point is the very same. So on this area, AC bat system. So this is adapter dock in, and this is AC detect, and this is what we have to check, shorting. You have merely 238 ohm. There is a no beeps on. So people get confused that if there is a no beeps on, he cannot determine that this is the short. But let me assure you that under 1 kilo ohm or 500 ohm, the 19 volt must have more than around minimum 500 ohm. Okay, and as much as it could be. Usually you will see more than 10 kilo ohms, but in the worst case, like if high drive or low drive is short, sometime it will release you this types of value. So the problem is that my DC in area, after the DC in the first MOSFET, so you can verify each and everything after removing second MOSFET. Okay, so we are going here in order to testify you that each and everything is all right except shorting. So shorting is if on the core area, the CPU is damaged usually, because most of the time I'm experienced in the many motherboards that if the core high drive area is short, CPU is not safe. So I'm going to remove the second MOSFET in order to verify. Okay, just remove it. This is the process. By following this, you can easily repair these types of problem. Don't miss this types of capacitor, because this is the very important capacitor. This is a charge pump capacitor, and where the 26 volt stay. So sometime 2200 picofarad, sometime it is used, one is used 2200 picofarad and one is 0.1 microfarad. So you have to match the value. So here the shorting is still persist. Now come to this area and shorting is removed, I think so, for me, because the system voltage is not short for me. Okay, still it is shorting. Now let's verify it. I have injected power. Do you have the 26 volt on this? Because both reached, both after both MOSFET, you don't, your charging IC will not release 26 volt at any cost. Now check it. It is still not uh, giving you voltage. It means the problem is from the charging area, not this area. Okay, the DC in voltage is here, and the gate biasing is not present. I think the guy, he has messed this capacitor, so just remove for the time being. You don't have to touch this capacitor unless or until you have water damage or it is physically damaged. You don't have to touch it. Now, no, it means I have verified it that the problem is on the charging area or the MOSFET side. If you have both N channel MOSFET, first and second, you just remove the second MOSFET and you will be able to verify. If the first MOSFET start getting 26 volt, so it means the problem is on the your mm, MOSFET area, or and if you are still not getting like this, it means the problem is on the charging area. Got this point? So I am trying to do one more thing. I'm showing you for the verification, but I am damn sure that the problem is on the charging area. Charging IC is not releasing due to any reason. uh, Charging IC is not releasing 28 volt AC drive. That the area has problem. The charging area has some problem. Okay, even I will capture it with a DSO, it will not show me. No, not at all. I'm not getting voltage. So two things, that my charging IC is not good. So let's come, or the requirement is failed. The requirement is failed of the charging IC, and my first suspect is on the charging IC. Later on these area, because I have removed the second FET, and AC short circuit protection will not allow you to be the voltage on the. So this is now the situation is that I have, after removing the second MOSFET, I made this area don't care condition. Okay, earlier it was short from the ground, but now I have removed that voltage, because that voltage cannot be generated. So it means this area. So now my AC, after removing first MOSFET, let's find out what do you have? Still you have low voltage. It means the problem you have to remove at any cost. So my theory is wrong at this point. So since this is directly connected with the sensing register, this point is directly connected to this area, and this area is short, and this area is choking your AC direct. This is the very simple logic. So first of all, at any cost you have to remove it. So let's come and remove the shorting. My charging IC is all right, it seems. After knowing this logic, so now come back and place back this MOSFET, okay, and find out shorting, because charging IC is faulty or charging IC requirement is fail. Both are the similar thing. Directly I was saying you that the charging IC is faulty. That was not okay. Okay, so charging IC requirements or charging IC itself. So just moved. The guy, he has changed because both MOSFET number is different. Now I'm scared about this area. I'm scared about the core PWM IC. If it is short, then no can save CPU. High drive, because I changed processor many times in the many gaming motherboards usually. So if I receive like BKXD, NJ, mm, NJH and NJJ, right now I am having 3 motherboards for PCH and CPU. So most of the time what I find that if high drive is short, so CPU is not, DMI area, SM bus area don't work. Now, so this is the point. I'm trying to see any physical so let me verify first of all what I am scared about. Okay, so this is the PWM IC. I have to remove it because see, mind it, what value I am showing you right now. So this is the value 227 ohm I'm getting, and this side is ground. Okay, so all the DC in area is same, so you can check anywhere. So after removing this 2, I have to verify this should not short, otherwise I will stop making this video. Because this is the PWM IC of MPS, and this also has the MPS core IC, and I don't have the programmer for MPS right now. It is at my office, and this contains PWM as well as high drive and low drive inside, and 19 volt if it is short, so all the impact goes to the CPU. So just remove this one, and also I will not stop myself to removing this one. This is just a verification, because further I have to fight with this case or not, it will be decided from here. Okay, safe. Okay, at any cost I can repair this motherboard now, I can guarantee you. So because the problem is in our country, that if the matter reaches to the processor, they refuse to because sometime, because the rare motherboard, this is the also rare motherboard, the rare motherboard, they prefer to uh, say us to repair. So just put it back, you can now put it back, or you better to put it back after finding short circuit place. So now come here and remove your gloves and inject some power. I am choosing the area of the very area. Okay, here I am going to inject. So let me, which was the ground. Okay, so here I have to inject some voltage. Come on. Okay, I have injected here, and let me set my DC power supply to 0 volt, and I'm going to switch my camera, and let's connect the ground on this area and power to the very point where I have injected. This is the very good point, a way of removing shorting if there is. I don't have thermal camera and I never needed for that. So I am going to increase power. You will see that how much level I have to increase. Now you see the variation started. After injecting 3 volt, I have seen something. So maybe choking, and I hope so. I am still increasing voltage. I am still increasing 8 volt, 10 volt. So now what I have to do, I have to check once again. After I stopped at 10 volt, 11 volt, now I will check. I have done nothing. I have not removed anything. See the value. It is open now. So this is called choking in the DC, and this is the very natural phenomena in the DC. Never need to surprise that where is the shorting. So now the situation is that you just set it on the uh, mega ohm and check where your shorting vanished. It is 3 kilo ohm. Okay, it is 3 kilo ohm. So do one thing, you just inject power now. Okay, and increase the voltage to 20 volt and check at least your DC in voltage, or the AC detect you can check by checking this point only. You can 2.1 volt, so there might be shorting. So it is gradually increasing, and you don't have voltage as of now, so that might be due to more shorting. So it is called leaky. So here you are not getting voltage, you are not getting voltage. After removing, what do you get? How much So it's still very low. So just once again inject power, set it to 9 to 10 volt, because at the very time we have checked, at the very point, increase gradually 10 volt. So I have injected 20 volt. So there is a nowhere problem. I hope so. Yes, there is. No, that I have, that is why I have removed that area. Okay, it is on, turning on and off. So the problem is now remaining at your uh, at your first MOSFET and second MOSFET. So come here, inject DC, and check the same thing, the AC direct voltage. 2.6 volt. See, after injecting, I have removed entire. It's dropping, I think. So there is a something leakage. So if you find this types of case, so only option you have left by uh, chopping the area. Like you, once you have removed the core area, graphic area, RAM area, after removing at last, after removing like RAM high drive area, if you started getting 19 volt in your motherboard, it means that area is faulty. So in this way you can remove shorting. Now you have seen that as I have injected 20 volt, we started getting AC detect at the same point, 2.3 volt, but gradually it is decreasing. So it means the voltage is dropping across this diode. Okay, across this diode, because that area is short. AC bat system area is short. Unless you remove the proper shorting, you cannot repair these types of motherboard. But inshallah, because this area is safe, so hopefully I will repair this. So maybe the video is too much long, and after repairing it, I will share the my experience, that whether it is repairable or not. I will in the second part I will inshallah bring forth the solution of this video. I hope guys that you like this, and please comment whatever you are having query. If you are interested in our course, you can contact to Mr. Dillar sir. And if you ever been our online video student and you want to update yourself, and you for a long time you were not in touch with us, so you can contact and you can update your course by paying a renewal charge, merely a very low amount of price you have to pay for the renewal server renewal charge, and you can get the all latest video which is available with us. So stay tuned for this types of case study. Thank you guys, thank you for watching this video.